Now I added this section to my chapter on radicals, but if you do not or have not covered functions, you might want to skip this section until you cover functions. But if you have covered functions, then you'll understand this. So I'll try to explain here. This is function notation, f of x. It means that whatever I plug into x here, I'm actually going to plug it into this this radical function here. So when it says evaluate this radical function f of x equals square root of x minus 5, if it says find f of 5, it just means that I go to the f function, which is this one, and I replace x with 5. So if I replace x with 5, that would be f of 5. I would get square root of 5 minus 5, which is the square root of 0, which is 0. Now the other function, g of x, is actually a cube root of 3x minus 1. And this says find g of 0, g evaluate at 0. So g evaluate at 0, we would plug a 0 in here for x, and so I'd get the cube root 3 times 0 minus 1. Well, 3 times 0 minus 1 is just minus 1, so that would just be the cube root of negative 1, which is negative 1. So f of 5 is 0, and g of 0 is negative 1. Okay, let's do a couple more. Let's say I want to do f of 9. So I go up here to this first function, and I plug 9 in for x, so I get the square root of 9 minus 5. So that'd be square root of 4, which is 2. And then let's say I want to do g of 3. So if I plug 3 in to the g function for x, I get the cube root of 3 times 3 minus 1. Well, 3 times 3 minus 1 is 8, so that would just mean I'm looking for the cube root of 8, which we know is 2. And then f of 4, if I want to evaluate this function at 4, it would be the square root of 4 minus 5, which would be the square root of negative 1, and the square root of negative 1 is not a real number. And then if I want to evaluate g of negative 5, then I get cube root of 3 times negative 5 minus 1. Well, 3 times negative 5 minus 1 is actually negative 16, so I get the cube root of negative 16. And you can take the cube root of negative numbers, but you can't take the square root of negative numbers. So the cube root of a negative 16, I can actually write negative 16 times negative 8 times 2. So if I write negative 16 as negative 8 times 2, then I can take the cube root of negative 8 out. The cube root of negative 8 is negative 2, and then I have to leave the 2 inside the radical. So that would be negative 2 times the cube root of 2. Now, let me show you the graph of some radical functions here. Now I'm just going to graph these by plotting points. For square root of x, if you want to graph the function square root of x, you can treat this f of x just like the y if you want to. That's the same as y. So y equals square root of x. Now I can't plug in numbers that are negative because you can't take the square root of a negative number and get a real number, but I can plug 0 in for x. So if x is 0, then that would tell me that I would get square root of 0 for y, which is 0. I can plug 1 in, and if I plug 1 in, I get square root of 1 for y, which is 1. So if x is 1, y is 1. Now I could plug 2 or 3 in, but those would be decimal numbers because square root of 2 and square root of 3 are not whole numbers. So let me go ahead and move on to 4. Let's say x is 4, and then y would be square root of 4, and square root of 4 is 2. And you could go on to the next perfect square, plug 9 in for x, and you get square root of 9 is 3, plug 16 in, you get square root of 16 is 4. But really, I just used these first 3 points, 0, 0, 1, 1, and 4, 2, to give you an idea of what this graph looks like. And then, of course, you know, if you wanted to, you could actually go out here one more, and that point there would be the point that would be the point 9, 3. But you can see if you connect the dots, it's going to be a curve that looks like this. Now, on this other one, I had to be careful because certain numbers you can't plug in here. So let's see what I can plug in. I plugged 3 in. When I plugged 3 in, I got square root of 0, which is 0. So I know it goes through the point, or contains the point 30. And then when I plugged 2 in, I got square root of 1, which is 1. So I know it goes through the point 21. And then when I plugged negative 1 in, that gave me 3 minus negative 1, which is 3 plus 1. So it gave me 4. So square root of 4 is 2. So at negative 1, I get 2, and so forth. And then, of course, if you plug negative 6 in, you'll get square root of 9, which will be out here somewhere. And you'll get 3 for the y value. So anyway, those points kind of go along and follow this path. And then the couple of cube root examples. For the cube root function, I wanted to find numbers I could take the cube root of. So I'm going to choose negative 8, since I can take the cube root of negative 8 and get negative 2, and that would be over here somewhere. And then I can take the cube root of negative 1, and the cube root of negative 1 is negative 1, so the point negative 1 would be right here. And the cube root of 0 is 0, so that would give me the point 0, 0. And then if I plug 1 in, the cube root of 1 is 1, so that would give me the point 1, 1. And then I'd have to go all the way to 8 to get a perfect cube. So the cube root of 8 would be 2, so I would have the point here, 8, 2. And then if you connect the dots here, it would give you a graph that looks kind of like this. And then here I did the same thing. The only difference here is that each of these values will be, that I got over here, I'm going to have to add 2 to each value. So if I add 2 to negative 2, I get 0. If I add 2 to negative 1, I get 1. If I add 2 to 0, I get 2. If I add 2 to 1, I get 3. And if I add 2 to 2, I get 4. So in other words, at negative 8, the y value is 0, which is right there. And at negative 1, the y value is 1, so it's going to be right there. And at 0, the y value is 2, which is right there. And at 1, the y value is 3, which is right there. And then at 8, the y value is 4, which is right there. So you can see it has the same general shape as this one over here does, but it's shifted up a couple of units. Okay, now let me just mention briefly about the domain of radical functions. Remember that whatever's in a square root has to be greater than or equal to 0, right? Because it can't be negative. So if I want to find the domain of a square root, I just say 3x plus 5 must be greater than or equal to 0, and then I solve that inequality, so 3x must be greater than or equal to negative 5, and then if I divide both sides by 3, x must be greater than or equal to negative 5/3, and of course in interval notation that would be the bracket negative 5/3 to infinity. On this one, since this is a cube root, I don't have any problems because x minus 3 can be any number. So the domain of this would be all real numbers, which in interval notation would just be from minus infinity to infinity. And then this last one here, 5 minus x, you do the same thing I did on the first one. The 5 minus x must be greater than or equal to 0. And I just moved the minus x over to the other side so it would become positive. But if you read that after you move the x over there, that actually reads, if you read it right to left, it reads x is less than or equal to 5. So that's what I wrote, x is less than or equal to 5. So x has to be less than or equal to 5, and the interval notation for x is less than or equal to 5 would be negative infinity to 5 with the bracket, because the 5 is part of the domain. And that is the lecture on radical functions. In the next section I'll talk to you about radical equations.